All right, hello everybody. This is 10.4, the chain rule. So just another derivative rule to make complicated functions easier to take a derivative of. Okay, so if f of x is a differentiable function and n is any real number, and we are given f of x equals u of x raised to the n, so a function being raised to the power of n, then what the chain rule says is that, down below here, this power will come to the front, which is right there. And just like any normal derivative, you'll take the 1 away, which is right there. So you have n times u of x to the n minus 1. And here's the chain rule part. So you must multiply it by the derivative of the inside function u prime of x. That's it. So what we can say to make chain rule really easy is this is the derivative of the outside function. So derivative of the outside function. Derivative of outside. And once you take the derivative of the outside function, you will multiply it by the derivative of the inside function. And that's how easy we can make it. Derivative of outside times derivative of inside. And once you get that rule down, that formula down, guess what? The rest is algebra. That's it. So keep chain rule really simple. Derivative of outside times derivative of inside. Okay. Let's try it out. Look at that. I wrote it down there. Derivative of the outside, the inside remains the same, times derivative of outside. All right. There are some rules for e, the derivative of e, and the derivative of the natural log using chain rule. Don't worry, Ted's not magically moving. My dog is behind him. Okay. So the chain rule for e to the g of x, well, what you're going to do here is when you take the chain rule derivative of this, you'll get e to the g of x, that remains the same, but then you will multiply it by the derivative of the function in the exponent. So you'll multiply it by g prime of x. So the derivative of e raised to any function is going to be e raised to that function times the derivative of that function. So the derivative of e to the g of x is e to the g of x times g prime of x. Okay. Don't worry, we'll get all the practice today. And then for the natural log, if you have the natural log of some function g of x, then the chain rule derivative is going to be 1 over g of x times the derivative of the inside function, g prime of x. So you get 1 over g of x times g prime of x, and you can put it together to become g prime of x over g of x, because you just multiply the fraction together. So that's what that becomes. All right, not crazy, right? Maybe just a little. Okay, let's try it out. Let's go ahead and try the chain rule out. So for the first one, they're already giving us the function. We don't have to simplify anything. We can just go ahead and use the chain rule. So using the chain rule, I'll get f prime of x, and we take the derivative of the outside, meaning that 4 comes down, and you get 4 times the inside stays the same, And then you take 1 away from the exponent that is there. So you get 4 times 3x plus 1 cubed. That is the derivative of the outside. And now you need to multiply it by the derivative of the inside. What is the derivative of 3x plus 1? The derivative of 3x plus 1 is just 3. Okay, there it is. The derivative is done. The calculus is done. Now, all we say here is outside number times outside number. That 4 times the 3, and we end up with f prime of x gives me 12 times 3x plus 1 cubed. And that's it. We can't do anything else. Do not try to take this 12 and distribute it in there. You cannot do that because 3x plus 1 is being raised to the third. In order to distribute that 12, you would have to rewrite 3x plus 1 3 more times, and then you can distribute the 12. But we don't have to do that. Oops. That's it. That's done. That's as simple as it's going to get. Okay. Next one. See? Chain rule. Not bad. B. Same thing here. Find the derivative of this function using chain rule. So we'll start with y prime. And using chain rule, once again, this power will come down and multiply that 3. So you'll get 21. The inside stays the same, and you take 1 away. So we get 21 x cubed plus 4 to the 6. That is the derivative of the outside. Now you multiply it by the derivative of the inside. And the derivative of x cubed plus 4 is 3x squared. That's it. Derivative is done. Chain rule is done. Algebra on. So we do the same as above. Outside number times outside number. And 21 times 3 should give me 63 x squared times x cubed plus 4 to the 6. That's it. Nothing else. Can't do anything else. Cannot distribute this 63 because this is being raised to the 6. This is as simple as it's going to get. Is that it? Those two? Okay. A lot of room. Okay, see, let's keep doing it. So derivative f prime of x, 1/2 comes down. Inside stays the same. Subtract 1. 1/2 minus 1 is negative 1/2. And then multiply it by the derivative of the inside, which is 4. All right. And like I said, calculus is done. Chain rule is done. Go ahead and clean it up. Outside number times outside number. 1/2 of 4. 1/2 times 4, that gives me 2. And you get 2 times 4x plus 3 to the negative 1/2. Okay, So now, this is a good answer, but if my math lab makes you rewrite it, then your rewrite is 2 over 4x plus 3 to the 1/2. Just flip that 4x plus 3 to the denominator. All right. So that could be your possible my math lab answer. Okay. Oh man, I really need to write bigger. I just won't zoom in as much. All right, do it again. F prime of x, we take the derivative. -3 comes down. Inside stays the same. And subtract 1. You get -4. There's a derivative of the outside. Now multiply it by the derivative of the inside. The derivative of x to the 5th plus 2 is 5x to the 4th. And then outside number times outside number. -15 x to the 4th times x to the 5th plus 2 to the -4. Good answer, but the my math lab answer might make you rewrite it as -15x to the 4th over x to the 5th plus 2 to the 4th. Okay. Okay. E. So before we do the chain rule, the derivative, we need to rewrite this. We could definitely take the derivative of this using quotient rule, but let's make our lives easier by just flipping it to the top and making the exponent negative. So this would become d over dt. And if you just take this, the denominator, and flip it to the top, it becomes t squared plus t plus 4 to the -3. And now we are ready to apply the chain rule. So that means -3 comes down, and we get -3 times the inside, which stays the same. Subtract 1, you get -4 times the derivative of the inside. So derivative of t squared plus t plus 4. That's going to be 2t plus 1. Okay, there it is. Derivative of outside times derivative of inside. Now, clean it up. Oops. Outside times outside. And you get -3 times 2t plus 1. I'm not distributing the 3 yet because on the last ones, it was only a 1 term. Now we have 2 terms. So we're going to leave that together like that. So -3 times 2t plus 1 times t squared plus t plus 4 to the -4. Now, once again, this is a good answer. But my math lab may have us write it as -3 times 2t plus 1 over t squared plus t plus 4 to the 4th. And if you want to distribute that -3, you can go ahead and distribute it. You'd get -6t minus 3 over the same denominator. If it makes you distribute it, then that's what you're going to have to do. But other than that, that's good. Okay, perfect. F. Just like above, we're going to have to rewrite this. So first we say h of w, and the square root of 3 minus w squared can be rewritten as 3 minus w squared to the 1/2. There's our rewrite. We just go from radical to rational exponent. And now we're ready to take the derivative using the chain rule. So h prime w, the 1/2 comes down. The inside stays the same. Subtract 1. 1/2 minus 1 is -1/2. Multiply it by the derivative of the inside. The derivative of 3 minus w squared is -2w. Okay. Calculus is done. Derivative's done. Chain rule's done. Algebra on from here. So h prime w, and then outside times outside, well, 1/2 times -2w should just leave me with -w times 3 minus w squared to the -1/2. Once again, perfect answer, but if it wants you to rewrite, you're going to get -w over 3 minus w squared to the 1/2. Okay. So in some of these, we had to rewrite and then take the derivative. The earlier ones, we did not. Okay. All right, G. Same thing. Let's take the derivative, and we're going to start with y prime. This 5 comes down, multiplies the 2. We're going to get 10. The inside stays the same. You subtract 1. You get 4. And that's the derivative of the outside. Then you multiply it by the derivative of the inside. X cubed plus 6, that's going to be 3x squared. And like I always say, derivative is done. Chain rule is done. Calculus is done. Algebra on from here. Outside times outside. Y prime is 30x squared times x cubed plus 6 to the 4th. Nothing else we can do there. Okay, h, d over dt of 3 times t cubed plus t squared minus t. Chain rule this, we're ready to go. So this is going to become, by chain rule, the negative 2 comes down, multiplies a 3. You get negative 6. The inside stays the same. You subtract 1, and we get negative 3. That's the derivative of the outside. And now we want to multiply by the derivative of the inside. The derivative of t cubed plus t squared is 3t squared plus 2t. 3t squared plus 2t. Okay, and calculus is done. Algebra on. Outside times outside. Negative 6 times 3t squared plus 2t. Not distributing the 6. We do not have to. And then t cubed plus t squared to the negative 3. This is a perfect answer, but there's always the but. We can rewrite this as negative 6 times 3t squared plus 2t over t cubed plus t squared to the third. And now if you want to distribute the negative 6, you can definitely distribute the negative 6. There's no stopping you. Students love to distribute. It's their favorite pastime. Okay. Oof, all right. Now we get to this one. The derivative of 2x squared times x cubed minus 3 to the fourth. So this has two functions inside. So when you have the derivative of two functions multiplying each other, we have to use a special rule. This is going to use product rule. So we have to product rule first. Can't spell rule. Product rule. So this means that the first function, 2x squared, is going to be f. The second function, x cubed minus 3 to the fourth, is going to be g. Now let's follow our product rule. F prime is 4x. G prime, well, look at this. G prime is going to use chain rule. This is going to use chain rule, which means the 4 comes to the front. So 4 times x cubed minus 3. The inside stays the same. You subtract 1. You get 4 times x cubed minus 3 to the third. That's the derivative of the outside. Then you multiply it by the derivative of the inside. X cubed minus 3, that derivative is 3x squared. Okay. And just clean it up. Outside times outside. And we will get 12x squared times x cubed minus 3 to the third. Okay, and then we are taking the derivative of this expression. So we have to start it back off that way. So we need to write d over dx 2x cubed minus 3 to the 4th equals, and now let's follow our chain rule. F prime g 4x times x cubed minus 3 to the 4th plus g prime f. There it is, g prime f. Okay, we have followed the product rule, and all the calculus is done. So now just clean up with algebra. Nothing but algebra, right? The easy part's done. The easy part's calculus. Now we clean up with nothing but algebra. So what I'm gonna do is rewrite this. So the first term, nothing happens here. We can't distribute anything. The second one, I can multiply these two terms. So 12x squared times 2x squared is 24x to the 4th, and this remains same. Okay, and I think my math lab wants us to keep going, and it's only right to keep going. So what we're gonna do next is factor. We're gonna look for greatest common factors. So between 4 and 24, I can take out a 4. And then between x and x to the 4th, here I'll put what we're factoring out in different colors. So I'll take a 4 out, and then from x and x to the 4th, I can only take an x out. And then from x cubed minus 3 to the 4th and x cubed minus 3 to the 3rd, you can only take the smallest power out. So I can take out an x cubed minus 3 to the 3rd. So this is our greatest common factor. Which means I'll put a bracket here just for neatness and write what we're gonna have left when we take out this greatest common factor. Okay, so you take out this greatest common factor, 4x from 4x, cancel. X cubed minus 3 to the 3rd, from x cubed minus 3 to the 4th, you will only be left with one of them left. So in here, I'll have just x cubed minus 3. Plus, let's do it again. 4x from 24x to the 4th. Well, 4 from 24, and when I say from, I mean divided from. So you take out a 4 from 24, we're going to get 6. And x from x to the 4th will give me x to the 3rd. And then x cubed minus 3 to the 3rd, from x cubed minus 3 to the 3rd, cancel. So that's all we're left with. And there we go. All we have left to do is clean up inside the brackets, and we are done. So rewrite my greatest common factor. And then don't need brackets anymore. All I have to do is say x cubed plus 6x cubed, and that will give me 7x cubed minus 3. Done, done, done. Now let's say it didn't want you to simplify at all. Let's say it just wanted a derivative and that was it. Actually, no, not that one. That could be your possible MyMathLab answer if it didn't want you to factor out. Okay, well, for your sake, let's hope it's the first one. For my sake, let's hope it's the last one. Okay. All right, so here's where we're going to use that special property for e to the x, the chain rule for e to the x. Let's see, do that in blue. So the derivative, the chain rule derivative for e to the gx, which is on the front page, is the derivative of the exponent times the original function e to the gx. So when we're taking the derivative of this, we'll say f prime of x, and I'll leave that -5 on the outside. And now let's just look at the chain rule derivative for e to the 12x. So what is the derivative of 12x? That is just going to be 12. So that's the derivative of the exponent times the original, oh, without the 5, the original function. That's it. This is exactly the same as that. And then you'll just multiply the two together, and our final answer will be -60e to the 12x. That's it. Nothing to it. All right, not crazy. Just looks a little crazy. This will use the chain rule for logs. So d over dx of the natural log of g of x is just derivative of the inside over the inside. That's it. Derivative of inside over the inside. So for this one, I'm going to take this 10 and move it to the front. So we should have 10 times the derivative of the natural log of x to the 9 plus 2. So what this is going to become is 10, and I'll put another bracket just for neatness. And to do the chain rule derivative for the natural log is you take the derivative of the inside, which is going to be 9x to the 8th, and put it over the original inside. There you go. That looks exactly like that. Derivative of inside over the inside. And then just multiply the 10 in. Remember, the 10 only goes to the numerator because you can see it as 10 over 1. So our final answer will be 90 x to the 8th over x to the 9 plus 2. There you go. So take some practice. Maybe a little hard to look at first, but just remember for the natural log, the chain rule for the natural log is derivative of inside over the inside. And I guess you could say the derivative for the exponential function e to the x is derivative of the exponent times the original exponential function. And then the derivative for any other regular function is always derivative of the outside times the inside. All right. I think we're on the last one. Okay. So application. The total cost in hundreds of dollars of producing X cameras per week is given by the cost function C of X equals 6 plus the square root of 4X plus 4, and we're given a domain of 0 to 30. So cameras must be between 0 and 30 cameras. Find the derivative and then interpret C prime of 15 and C prime of 24. So all we have to do here is take the derivative using chain rule, and then for B, plug in 15, 24, interpret the results. So for A, we first have to rewrite the cost function. Six plus, and then you would have 4x plus 4 to the 1/2. That's it. We just had to go from radical to rational. We are now ready for the derivative, and you get C prime of X, the derivative of 6. It's a constant. The derivative of 6 is 0. And then the chain rule derivative for 4x plus 4 to the 1/2 is that 1/2 comes down. The inside stays the same. The new exponent becomes negative 1/2, right? 1/2 comes down. You subtract 1. You get that to the negative 1/2. And then don't forget to multiply by the derivative of the inside. And the derivative of 4x plus 4 is just 4. Okay. Clean it up. And we get C prime of X is equal to, and we do outside number times outside number, and we end up with 2 times 4x plus 4 to the negative 1/2, which is good. But remember, it can also be rewritten as 2 over 4x plus 4 to the 1/2. Okay. Now all we have to do for B is plug in 15 and 24 and interpret. Okay, and let's see if I have my calculator. We can type that in. Okay, so I'm just going to type this function into my calculator as I see it. I'll do 2, and then I have a fraction button somewhere over, and I'm going to type it in just like that. Parentheses 4x plus 4, and raise it to the 1/2. Well, 1/2 is 0.5, so that's just going to make our life easier if I put 0.5. Okay, let's say you don't have that fraction button and you have to do classic input. I would write it as, as that one you see in the screen. So I would say 2 parentheses 4x plus 4 and raise it to the negative 0.5. Either one works. We're going to get the same answer. So that's how you would type it in, just any classic input. Okay, and then after that, enter. I'll do second window. Make sure make sure independent is on ask. If it's not, highlight ask, hit enter, and then hit second and graph, and you get the table. And what we're plugging in is 15. If there's values there as well, you can delete them. So I can say delete, 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 delete. And I'll say 15, and we get 0.25. All right. And then we're doing 24. Okay, excellent. So now come back to the notes. And all we have to do now is just interpret what it means. So we took the derivative of the cost function. Remember that derivative is the same as slope. It's a rate of change. And if we get a positive number output, this means that our rate of change, our slope, is increasing. So this problem has total cost in hundreds of dollars of producing X cameras per week. So if X represents cameras, what we can say for 15, when we plug in 15 cameras, the cost is increasing by 25 cents per camera. So cost is increasing by 25 cents per camera. And if you make 24 cameras, if you produce 24 cameras, cost only increases by 20 cents. So we could just say for this one, at 15 cameras, cost increases by 25 cents per camera. And then the next one, basically the same statement. At 24 cameras, and there it is. And that is chain rule. Just follow the formula, like I said, for product and quotient. For chain rule, follow the formula, keep it simple, derivative of outside times derivative of inside, and then clean up algebraically. That is it. Okay, until next time.